Hi guys, so we're gonna do some real short, kind of like housekeeping, just making sure you understand what we're doing. You should be taking uh, notes every day, like when we take notes, the way that you take notes, we'll need to focus on the Cornell style, which means your key points will be over here. Key points can be vocabulary or the concept that we're covering. And then the support is the information that backs up your point, or it defines it, or is an example. I know that if you're an avid, you write questions over here, and then this answer on this side. The way that we've done it in science, according to the Cornell website, is that the key points that are over here can be questions. It can totally be a question, but it also can be a concept, a word, a word to define, like a vocabulary term. If you need help setting it up to do specific for Avid, then come see me and I'll show you how to do that. And then your summary down here, a lot of the time it's going to be answering the EQ, or it may be part of homework, or you may just have to do it on your own. Most of the time we will write like we're not going to do a summary, and then it will be your job outside of class to do your summary. So let's look at what are some of these pictures, or these letters. What are they? What does a KHD BDCM mean? Well, hopefully you know that these are units of measurement. And the second question is, why are some of these letters in lowercase? So let's look at symmetric system basics. And our EQ is, why do scientists use a metric system versus like any system? Like, why is science measurement specifically done in metric? So on your paper, probably on the back of the pictures that go with your notes today, you'll have this little stair step, and we're going to put those letters that were on the second slide, the KHDBDCM, in the white boxes, and then we're going to write what their prefix is out to the side. So the K is for kilo, or kilo. The H is for hecto. We usually don't use this one. This is mainly done in the medical field. And then you've got deca. Again, we usually don't use this one. And then B is for base. And then deci, we usually don't use this one. This one is also a medical field. And then these two down here we use a lot of centi and milli. So this base part here is where you would find meters or liters, or my brain just went, pick Skittles. So this would be like where you're doing kilometers or kilograms. The B would be for whatever type of measurement you're doing. So looking at the metric system, the metric system is done in base 10, which means the units increase by 10 each time as they go up, or I should say place 10. So we use meters to measure length, and we use liters to measure volume. Usually this is in liquids. And then we use grams to measure mass. We would say weight. Most people would say, how much does it weigh? But it's really finding its mass. The prefix and the base unit give me my measurements. So centi plus meters gives me, oh my gosh, centimeters. Kilo plus liter gives me kiloliters. The three prefixes we use the most, like I said in the other slide, are kilo, centi, and milli. So if you look, kilo is 1,000 base units. So if 1 is like a base unit of a meter, a kilo would be 1,000 meters. And centi is 0.01 of its base unit. So because I moved down, so here's my base, I moved down 1, a deci would be 0.1 base unit. Centi is 0.01 base unit. So the prefixes are based on powers of 10, and that is like a multiplication of 10. So each step, down the step or across the steps, as we look at the picture below, are 10 times bigger or smaller than the box that you moved from. So an example, centimeters are 10 times bigger than a millimeter. So if I look down here on the bottom, if I'm moving to the left, I'm going to go bigger numbers. If I move to the right, then I would be going into smaller numbers. So the summary in this part, the base units, meters, liters, and grams, are our metric system that we use. And the metric system is powers of 10 for conversion. So you'll have lots of practice. I think one of your homework assignments is to do some of these conversions. So variables. This is super important. Please, if you've been kind of drifting in and out, pay attention for this part. It is más importante. So we're going to look at the 3 types of variables, and we're going to look at how do we identify them when we're doing our lab work or other activities. So our variables are things that vary. If you caught the little guy over here with scratching his head, variables change and vary. So if you look, vary, V-A-R-I, vary, V-A-R-Y, that means to change. An independent variable is the one that's the input. It's the one that I, as the experimenter, as the scientist, can change. The dependent one is the outcome. It's the thing that depends on something else. And the control is the one that I don't really move around or change. So we've got a little experiment over here that we're going to look at. The independent variable first. If you notice, I wrote the IN in the orange and the input in orange. So this is to help us remember the thing that I can change. If you remember dry mix from 6th and 7th grade, this would go on the x-axis because it's the I change, and the independent. So we're going to, first investigation that we're going to look at to help us identify is how does weight affect the length of a rubber band? So I've got a caliper here, which is basically just something that works like a little claw. I've got a rubber band, and then I'm putting these little weights on, and I'm measuring how far the rubber band stretches. So the thing that I decide is the amount of weight to apply in this experiment. So this is the thing that I can change. So my weights are my independent variable. So the other experiment that we're going to look at, and this is the part where you have to put some thought in and hopefully get some answers proper. The independent variable, again, is the thing that I can change. So the investigation is how the rate of water cools in a beaker. So what are you going to decide? What is the independent variable that you have control over? Hopefully, you are in control of the water. So are you going to use room temperature water? Are you going to use cold water? Are you going to use hot water? The dependent variable, the outcome, is the thing that changes as a result. So looking back at our rubber bands, I controlled the weight of the rubber bands. So the weights in the rubber bands, you're measuring the result of the length of the rubber bands. So the thing that changed was the length in rubber bands. So looking at our water, looking at the rate water cools, I measure the temperature every minute as it cools. Blank is the dependent variable. So boop, 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 ba-doo, ba-doo, ba. Hopefully you have that the temperature over time is the thing that changed. Control variables. These are the things that can't change. No matter how much I want to, I cannot change them because this keeps the test fair and reliable. So that means that other scientists or other students can depend on my results. So the weights affecting the length of a rubber band, my first test, remember I controlled the weights. So the independent variable was the weights. The dependent variable was the amount of stretch or the length that it moved. So I have to use the same rubber bands throughout the entire test. And I have to use the same scale. So if I'm using a ruler, I have to use the same ruler the entire test. The control variables in my cooling water. I must use the same beaker, the same amount of water, and the same placement in the room. The same temperature of the room. I can't go in between two teachers' rooms because now I'm looking at the room temperature also affecting the rate that the water cooled at. So tables. Last year we saw students really struggle with this. So please, when you make your tables, You're going to have to label your independent variables. They're going to go in this first column. And then your dependent variables. What are the things that you're measuring? So you'll take multiple readings and then you find a mean or an average of those. This also keeps your test reliable and trusted so that others can depend on the information. So we're going to design a quick list of variables. You will have to do this as part of your weekly writing. This will be as part of your summary. So your hypothesis is the farther a ball drops, the higher it will bounce. So you need to design a table. You will, with your table partner, design an investigation to test this hypothesis. You must list the variables. That is the dependent, the independent, and the control variables. You need to look at what exactly will be changed. What are you testing? How will it be changed? And then how exactly will you measure? And how will it be measured? So are you going to measure the same person measuring your height? Are you going to use the same meter stick? So just make sure that you keep all of these things very, very clear. So this is part of your summary on your notes. So good luck. I'll see you on the other side.